We're going to do a good classic mechanics problem involving Newton's laws. We have a truck over here. The truck is moving a bunch of boxes and packages. So let's focus on one of the boxes here. Let's say the coefficient of kinetic friction between the box and the truck is 0.1. The coefficient of static friction is unknown. Okay? And the distance from the back of the box to the back of the truck is 2 meters. It's kind of like you're moving and you rent a U-Haul or something. Let's say the truck wants to accelerate at a rate of 4 meters per second squared. That's going to be the desired acceleration of the truck. And then here there are some questions. What should be the minimum μs? So what should this be at minimum for the box to accelerate with the truck? If you wanted to accelerate along with the truck at a rate of 4 meters per second squared. B will ask this question. What if μs is less than that minimum value? If there isn't sufficient friction, then what's going to happen? What is the acceleration of the box? How long does it take it to hit the back of the truck? So what's going to happen is, if there isn't sufficient friction, the truck is going to accelerate really quickly. The box is not going to be able to accelerate along with the truck, and the box is going to feel like it's moving backwards with respect to the truck, right? And so it's going to hit the back of the truck over here, and if the back of the truck was open, of course, it'll fall, you'll lose it, right? And then part C says, how far has the truck gone in this time? So how long does it take it to hit the back of the truck, and then how far has the truck gone during that time period? Okay, so kind of an interesting problem here. So what's going to happen here, let's analyze the forces on the box. We have the normal force, we have mg, okay? And notice it didn't tell us the mass of the box. The problem doesn't need to give us the mass. Now it's interesting here, this kind of a situation, which direction is the friction force? Well, the natural inclination of the box is to stand in place. It doesn't want to accelerate with the truck. So the friction force is in the direction of the acceleration of the truck. And the maximum static friction is going to be μSn. So this problem represents a kind of case where the friction is actually causing the box to move forward along with the truck. Instead of fighting against, instead of being in the backward direction, it's actually causing the acceleration of the box with respect to the road, okay? So it's kind of fighting against the natural inclination of what the box wants to do, the inertia of the box. So we have μSn is forward. So μSn is the only forward force. It needs to equal ma. And n is equal to mg. μs is equal to a over g. And that's it. As long as μs is equal to the ratio of what the car is accelerating at divided by g, then you have sufficient friction to accelerate with the truck. So what is this equal to? 4 divided by 9.8. Okay, that's going to be, so this is 4 here. μs minimum comes out 0.408. So minimum coefficient of static friction you need over there is 0.408. Let's say there isn't sufficient friction. Okay, so part B, what is going to happen to the box? Well, the box's inertia is going to want to make it stand back. Kinetic friction will kick in. The box is going to start sliding backwards with respect to the truck. Okay? So let's erase this here. So now we have the box like this. You have N, you have mg, you have μkn. Okay? So now the kinetic friction is pushing it forward, trying to help make it accelerate. Okay, so now we have μkn is equal to ma, and then μk is given in the problem, 0.1. 0.1 times mg is equal to ma. Mm cancels, the mass in the box still cancels. So we have 0.1 times 9.8 is equal to A. A is equal to 0.98 meters per second squared. So which direction is the acceleration of the box? Well, with respect to the road, the box is accelerating forward at 0.98 meters per second squared. You see, so a person sitting outside is going to see the whole system. It's going to go like this. The truck has moved, let's say, over here. Okay, goes like that. The truck has moved like this. The box has now, eventually the box is going to be at the back of the truck, right? So, drawing a quick truck here. So the box has moved forward, okay, with an acceleration 0.98 with respect to the road, right? But the truck is accelerating forward with an acceleration of 4, right? So let's analyze it with respect to what's happening in the truck, from the truck's perspective. If the truck is accelerating forward at 4, and if the box is accelerating forward at 0.98 meters per second squared, what's the acceleration of the box with respect to the truck? Okay? So acceleration of the box with respect to truck is going to equal 0.98 minus 4. Right? The box is accelerating forward. The truck is accelerating forward faster. So it looks like the box is accelerating backwards, right? So 0.98 minus 4. Acceleration of, we can call this acceleration prime. Acceleration, that's negative 0.302 meters per second squared. So with respect to the truck, the box is accelerating backward at 3.02 meters per second squared. How long will it take it to travel a distance of 2 meters? Okay, so we have d equals v initial t plus half a t squared, right? The kinematics equation. The initial velocity of the box is 0, so the distance d is 2 meters. Now in this case it's negative 2 meters, right? Because it's traveling back. Negative 2, half a is negative 3.02 t squared. So really we don't even need the negatives. The negatives cancel, right? So the box is traveling 2 meters, it's traveling backwards, it's accelerating at a relative acceleration of 3.02. What's the time? T is equal to 4 divided by 3.02 square root. 0.15. So in the time of 1.15 seconds, the box is going to hit the back of the truck. Okay? Now, what's going to happen? How far is the box traveling in the meantime? Okay? So that's pretty good, straightforward question. Distance of the truck is equal to v initial t plus half a t squared. So it all depends on what the initial velocity of the truck was before it started accelerating. So let's say the truck was going at 2 meters per second, and then it accelerated at 4 meters per second squared. So we have d is equal to 2 times the time. The time is equal to 1.15 plus half times 4 times 1.15 squared. Okay? 4.95 meters. This is the distance that the truck has traveled during the time that the box took to hit the back of the truck, with respect to a person from the outside observer. Okay? Distance that the truck traveled. What's the distance that the box traveled with respect to an outside observer? Well, also the initial t plus half a t squared. Okay, what was the initial velocity of the box. The box was also going at 2 meters per second, right? 2 times 1.15 plus half. What was the acceleration of the box? Okay? Forward with respect to an outside observer. So that's 0.98 times 1.15 squared. So 2 times 2.95 meters. Okay? So with respect to an outside observer, the box moved forward 2.95. The truck moved forward 4.95. Subtract the 2. 4.95 minus 2.95. What's the difference? Distance truck minus distance box. 4.95 minus 2.95, 2 meters. Which is the distance that the box traveled backwards with respect to the truck. So the difference is 2.